Hello, hello, hello. Yes, guys, I think audio you can check now. Audio must be there. Was on mute. Very, very good afternoon, everyone. Yes, guys, I think audio you can check now. Audio must be there. Was on mute. Very, very good afternoon, everyone. I was a bit struggling with the audio only. That is the reason the session got delayed, and you just have to confirm that. Good afternoon, everybody. Okay, good afternoon, Lucky. Good afternoon, Suresh Reddy. Good afternoon, Sujata. Bit struggling with the audio only. That is the reason the session got delayed, and you just have to confirm that. Good afternoon, everybody. Okay, good afternoon, Lucky. Good afternoon, sorry. Bit struggling with the audio only. That is the okay. Can you confirm the audio at your end? How are you able to receive the audio? Right. Okay. 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 Just check it out again. Okay, students, let's get started and see if the problem still persists. Okay, very, very good afternoon, everyone. There's a session on microprocessor, and before we start up, important updates for all of you. Okay, is that the AEE test series, AEE test series is now live with all the full tests now also live. Okay, they were like live sequentially on 13th, 16th, and 18th August, and since it is 22nd August, and your exam, okay, for electrical students is on 26th and 27th. Okay, so that means you have still time. You can appear in all the three mock tests, and they are all live. And this is again on the Om Live app. Okay, this is on the Om Live app. Just for rupees 89, you can appear in the three mock tests. Huge response has come up. Lot many students writing this examination, so you can test, okay, and feel like a real competitive atmosphere and see your performance, see your mistakes, and finally, eventually, where you can improve when the exam is on 26th and 27th, respectively. Okay, right. Very, very good afternoon, everybody. Audio issue is still there. Hello, 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 hello. Okay. I think that's an internal system issue. Mic is okay only. Maybe some internal system issue is there which is not being figured out right now. Okay, anyways, okay, let me get started with the first question here and let us see. Okay, while moving towards the question, is the audio manageable or not? Otherwise, we have to find some other alternative. Okay, so the following 5 instructions were executed on 8085 microprocessor. As you have seen in the session of control systems, as you have seen in the session of aptitude and reasoning, we'll be revising through questions. So not only questions, relevant theory background required, I'll keep discussing. Acha, one more thing for your quick and thorough revision, the entire instruction set of 8085, okay, I have included in this PDF. Okay, and once I send you this PDF, you'll get the entire instruction set. Okay, right, I'm not going to go to instruction here one by one. Okay, but yeah, whatever instructions required, that will keep asking you, that will keep discussing, like, okay. And there are some programming questions, there are some few memory questions I've taken, and there are some bit theoretical question which is of course expected from microprocessor, right? This PDF will get the entire instruction set. Okay, right, I'm not going to go to instruction here one by one. Okay, but yeah, whatever instructions required, that will keep asking you. I think some sort of disturbance is still there, but you have to let me know, is it manageable or do I have to find an alternative here? Okay, have a look in, see, MVI A comma 33. Okay, look into this instruction, MVI A comma 33. Okay, now what is this MVI? Move immediate. So one thing I'll show you, I told you something and I'll show you, okay, so that you are a bit relaxed with respect to that point. See, what is that I want to show you here? What is that I want to show you here is, just 1 second. Okay. With questions I'm revising, but for your fully thorough revision in the PDF, I will give all these slides, all data transfer instructions, okay, move, LXI, LDA, ST, everything. And when questions also, I'll keep explaining this, all, arithmetic instructions, all logical instructions, like that, everything I've included, so that whenever I share this PDF, okay, you can thoroughly revise the entire subject. So have a look into this one. Okay, MVI A comma 33. Okay, move immediate. Okay, it will load the immediate data 33 into the accumulator. 33H for hexa. Okay, then MVI B comma 78. Okay, it will load the data 78 into the register B, and then add B in all arithmetic operations, or rather I will say in most of the arithmetic operation. Okay, accumulator is one of the operand. Okay, so add B means add with what? Add the content of B with that of the accumulator, and the result is stored back in the accumulator. Okay, so what is going to be the result here? Now 33 plus 78 have to be added, and please mind it, one common mistake that students will normally do is they will add it in decimal. Remember, it is hexa. Mic is still there. The audio problem is still there. Students are commenting that audio problem is still there. Result is stored back in the accumulator. Okay, so what is going to be the result here? Now 33. Some time I'll again check it. All right. Yeah, some answers have started coming up. Yeah, so I was trying to tell you that please mind it, you're going to edit in hexadecimal, not in decimal. Okay, so 8 plus 3 will not be 11 here. 8 plus 3 will be what? 9A and B. 9A and B. This is going to be B. And 7 plus 3, 8, 9 and A. Okay, right. So this is going to be A and B. This is going to be A and B. Now, what is CMA? CMA is the command to complement the contents of accumulator. Complement the contents of accumulator. Now, complement means what? Normally, complement means ones complement here. Now, there are two things you can do here. Okay, ones complement. Okay, normally the data stored in microprocessor will be what? Binary, na? So you'll have to take ones complement in binary. But remember, ones complement in binary, you can call it as F's complement in hexadecimal number system. You can call it as F's complement in the hexadecimal number system. Okay. Right. So when you're going to take the hexadecimal, okay, every digit by F, so F minus B will be how much? 4. F minus A will be how much? 5. Okay, so what is going to be the contents of accumulator after the CMA command? Okay, after the CMA command, accumulator will contain how much of the data? 5, 4. Okay, 5, 4. You can do it in binary also, one and the same thing. Okay, you can do it in hexadecimal also by subtracting every particular hexadecimal digit by F. Okay, every particular hexadecimal digit by F. Of accumulator after the CMA command. Okay, let's move forward now. Okay, so now next instruction is ANI, and immediate. Okay, and immediate ANI 32. Okay, ANI 32. Now, when I do and immediate, okay, this is going to do what? Okay, what is this instruction going to do? Let me write this separately. Okay, A is equal to A and with the immediate data, that is 32. And with the immediate data, that is 32. Okay, and that is going to be, now whenever ANDing is done, it has to be bitwise ANDing. Okay, so how are we going to deal with this bitwise ANDing? Let's take it out here. See how we are going to do with this bitwise ANDing. Okay, what is the contents of accumulator? 5, 4. 5 is 0, 1, 0, 1. 4 is 0, 1, 0, 0. This has to be ANDed with what? This has to be ANDed with 3, 2. Okay, this has to be ANDed with the data, that is 3, 2. 0, 0, 1, 1 and 0, 0, 1, 0. 0, 0, 1, 1, 0, 0, 1, 1, 1, 0. Correct. This is what the ANDing to be done. This is 0, 0, 0. Bitwise ANDing, any bit 0, output will be 0. Only when both the bits are high, output will be high. Okay, 1 into 1 will be 1. Then this is 0, this is 0, this is 0. Okay, this is total 1 and this is total 0. Okay, so after I have done the AND operation, what is the contents, in the accumulator? Okay, is 1 and 0. That is what I got. Check here, 1 and 0. Is it okay, everybody? Okay, so the answer is B. What are the accumulator value immediately after the execution of the fifth instruction? Okay, this is the fifth instruction sequence. Right, lucky, correct answer. Answer has to be B. The correct answer has. What are the okay, next. As I've told you, all instructions I've included. Okay, before I show you this, okay, I just want to ask you a question. In the previous question, there was a command CMA. Okay, how there can be some more basic questions like this. The complement accumulator CMA instruction of 8085 processor on execution affects which flag? Okay, it is going to affect which flag? The CMA instruction will affect which flag? 0 flag, sign flag, carry flag, none of these. Okay, if you know it, let me know. Okay, I told you some questions can be knowledge or factual based on the microprocessor. If you know it, please let me know. The CMA will affect which flag? The CMA will affect which flag? Okay, the CMA is going to affect which flag? So see, some exceptions that normally you should know. Answers coming up here is A. Okay, I'll tell you. Arithmetic instructions will keep revising with question, but flag exceptions I want to tell you, okay, is that INR and DCR, whenever INR DCR come, they do not affect the carry flag, CY flag, and whenever INX and DCX will come, they do not affect any flag. They do not affect any flag. If you want to know the entire flag register, if you want to know the entire flag structure, let's go to that as well. Okay, let's go to that as well. See, you should be aware about 8085 registers. Okay, you should be thoroughly aware about the 8085 registers. Okay, the registers in 8085, okay, accumulator, okay, which can store 8-bit data, but at the same time, accumulator, okay, it's not only for storing the data, okay, it is mostly considered as a part of ALU because the result of most of the arithmetic and logical operation is stored in accumulator, and by default one of the operand is in accumulator. Okay, so if you just want to talk about general purpose registers whose role is to store the data, so they are B, C, D, E, H and L. Okay, so this is what B, C, D, E, H, L. These are 6 general purpose registers, and accumulator, okay, which is fundamentally tied to the ALU. That's what I told you. Okay, and other than that, okay, there is the flag register. Very important, you should know about all the 5 flags. So if I go to the flag register here, if I go to the flag register, again it's a 8-bit register. All registers here are 8-bit registers, okay, and then any register responsible for handling address is a 16-bit register. I'll come to that as well. Okay, now flag register is also 8-bit register, and 8-bit register, you know what, is a combination of 8 flip-flops, but only 5 flip-flops are used, 3 are unused. What are the 5 flip-flops that are used? Okay, sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Okay, what is sign flag? What is zero flag? Now see, sign flag is used to reflect the sign. What do you know about the sign? Whenever it's a positive number, MSB is 1. Okay, whenever it's a negative number, okay, sorry, I told reverse, I think. Whenever it's a positive number, MSB is 0. Whenever it's a negative number, MSB is equal to 1. That is what we know. Okay, so see, sign flag is 1 if the result is negative. Okay, to indicate negative number, it will just copy the MSB of the number and store it in the sign bit. The zero flag is set if the ALU result is exactly 0. Okay. Auxiliary carry is set if there is an internal carry from D3 to D4, from lower order nibble to the higher order nibble. Okay, parity flag is set if the result has even number of ones. Parity flag here is even parity flag, and carry flag is set if the arithmetic results in final carry. Like for example, go back to the previous question, one of the previous question. Okay, like here. Okay, this was the ANI instruction. This was the ANI instruction. Or here we have done that add instruction. Come here. Okay, here we have done that add instruction. Okay, if I show you this add instruction once again, okay, what we have done, 7, 8 plus 3, 3, or I can take any fresh addition instruction. Suppose you are doing what is the addition of this? Okay, tell me what is going to be the addition of this. Now A plus 6 in hexadecimal, B, C, D, E, F. What comes after F? 1, 0. Right. B, C, D, E, F, 1, 0. Right. That is what, is the result coming up. Okay. Okay, Lucky. Right. So, I was telling what comes after F is 1, 0. So, A plus 6 will be 1, 0. 0 is sum, 1 is the carry. Now, this is the internal carry from the lower order nibble to the higher order nibble. This is what is known as auxiliary carry. Now, 1 plus 2 plus 3 is 6. Is there any final carry here? Is there any final carry here? No final carry. That is what is carry flag is 0. Okay. Now, when I open this result in binary, what is 6? 0, 1, 1, 0 and 0, 0, 0, 0. Now, see. Okay, what is the status of the flags? Okay, what is the status of the flags for this particular case? Okay, that is sign flag is 0. Sign flag will copy MSB, result positive number, sign flag 0. Okay, then I told you zero flag. The zero flag will be 0 if the result after an arithmetic or logical operation is 0 inside the accumulator. Is this a 0 result? This is a non-zero result. Okay, so 0 flag is not set. Auxiliary carry flag is set as I have shown you. Okay, parity flag. The parity flag is set if the result contain even number of ones. Okay, are there even number of ones? Okay, yes. Okay, there are 2 number of ones. There are total 2 ones. Total, there are 2 ones. Okay, so parity flag is set. And what about, the carry flag? Carry flag means if there is a final carry in the last stage of addition, if there was a carry, okay, coming here, then that will be the main carry. Okay, which is not coming here, so carry flag is 0. Understood? Carry flag is 0. Carry flag is what? Carry flag is 0. Now, right, this was the first question which was done. Okay, so a second question I was trying to ask you about the flag. Okay, logical operation, again they will implicitly assume that accumulator is one of the operand. All logical operations reset the carry flag except CMA. CMA does not affect any flag. The CMA does not affect any flag. That was my question. Okay, so there can be those statement question. Arithmetic, what is the flag exception? You should know. In arithmetic, you should know that INR, DCR do not affect carry flag, and INX and DCX, okay, they will not affect any of the flags. Okay, DAD only affect the carry flag. Okay, whenever particular requirement is coming, I will explain you this instructions also. Okay, in the form of question. So CMA, okay, it affects which flag? Answer has to be D. Some of you telling A, no, it does not affect any flag. So answer for this question has to be what? Answer for this question has to be D. For this question has to be D. Explain you this instructions also. Okay, in the tell me. Okay, the correct answer is D here. Okay, the correct answer is D here. Next question. Okay, if the contents of an accumulator are XORed with itself and placed in the accumulator itself, then what is going to happen? Now, XOR operation. Okay, XOR operation. Okay, what is going to happen if the contents of accumulator are XORed with itself? That means they are talking about A equal to A XOR with A. A is equal to the A XOR with A. Okay, what is going to be happen? Okay, will the carry flag be set? What I told you right now. Okay, when I talk about logical operations, including AND or XOR, okay, they will all reset the carry flag. Okay, they will all reset the carry flag. So, carry flag will not be set. Carry flag will be reset. Okay. Okay, what is going to be the answer here? Okay, XOR, whenever the two bits are same, XOR answer is 0. Whenever bits are different, XOR answer is high. You will do bit by bit XOR. You will do bit by bit XOR. But remember, okay, both are same number A and A. Okay, both bits will be same. Okay, so the result will be in 8-bit format, or result will be all 0, and in hexadecimal format, I will write it as 0, 0. The accumulator contain all ones? No, accumulator contain all zeros actually. Okay, accumulator contain all zeros. Okay, the 0 flag is set when the result after arithmetic or logical operation results in 0. Okay, so the 0 flag has to be set. So the 0 flag has to be set. The correct answer has to be option number C. 0 flag has to be set here, correct? Okay, the accumulator contents are shifted left. No, there is no shifting logic here. Okay, so C answer is the correct one here. Okay, Rutvik, correct. C answer is the correct answer for this question. Okay, let us go to the fourth question. Which of the following is a 8-bit register? Okay, so I am about to go to tell you about program counter and stack counter. Okay, right, but the 8-bit register is the accumulator. See, this picture I have shown you, na? This picture I have shown you. Accumulator and flag register are 8-bit registers. Then BCDEHL, general purpose registers. Okay, and okay, stack pointer and program counter, which are 16-bit register. What is their role? Okay, right now the answer is simply A, accumulator. Okay, what are their role? Okay, I explained you about this. I explained you about the flag register. Okay, now program counter. It is responsible for sequencing. Okay. Sir, if A is 1, what happened? No, lucky because you are going to do A XOR A. Okay, anything. Okay, you are going to do A XOR A. That means same number. Okay, XOR you are going to do for the same number. Answer has to be 0. That is what I just told. Okay. Okay, program counter and stack pointer. Program counter is primarily responsible for sequencing, okay, the execution of program. Okay, it points directly to the memory address of the next byte to be fetched. It directly points to the memory address of the next instruction to be fetched, next byte to be fetched. Getting? Okay, so instructions are stored in the memory. Now, from which memory location next instruction has to be executed? That is taken care by program counter. Okay, that is taken care by program counter. Whatever address is stored in program counter, microprocessor will go to that address and pick up the instruction from there, and whatever instruction is written, it will start executing that instruction. It will start executing that instruction. Stack pointer for managing the temporary stack memory. Okay, it manages the temporary memory known as stack memory. Okay, so it will also contain a 16-bit address. Okay, it will also contain a 16-bit address pointing to the dedicated portion of read-write memory, okay, which is known as stack, used for temporary storage of data. Okay, so it holds the memory location of the top of the stack. Okay, you can say that this is what is shown here. It holds the memory location of the top of the stack. Okay, top of the stack. Okay, with example, when push and pop instruction will come, I'll explain you that also with example. Yeah, Mr. Praveen Kumar, correct. If accumulator are all zeros, then CMA will give all ones, correct. That is true. Okay, that is true. Okay. So now see, what can be another question? What is the length of stack pointer? Okay, what is the length of the stack pointer? Okay, 16 bits. Tick mark. Few questions are just tick mark and they really do come in the exam. That is why I've taken few questions of this nature. Okay, you are really close to the exam, so I want to take the questions which can be expected in exam. Few simple and few programming based also, few memory based also. Okay, right. I again apologize if audio is bit creating a problem. If it is creating a lot of problem, do let me know. Okay, we'll have to reschedule only because everything I've tried, that is the reason it got delayed. But if it is manageable, okay, I really appreciate if you can manage and follow it. I apologize, I have no solution that is coming up on the spot. Okay, but if it is a big problem, please let me know. I'll have to reschedule. That is the only option. If it is manageable, let's continue. Okay, so please comment now. I want to know the comments of maximum people. Okay, about with respect to the audio. I know there is some issue and that is not being rectified on the spot right now. Okay. Question number 6. The register in the 8085 microprocessor that is used to keep track of the memory address of the next opcode, okay, to be run. Okay, memory address of the next opcode, next instruction to be run in the program. Okay, that register is known as program counter. That register is what is known as the program counter. That is option number B. You have to tick mark here. Okay, right. It's like this have come up in the examination. That is the reason I am taking that as well. Okay, next one. Now, have a look into this question. Okay, question, from which address will the next instruction be fetched? See, what is the final question? From which address will the next instruction be fetched? The next instruction is fetched from the address which is stored. Okay. Very close programming I will make from address stored in the program counter. From the address stored in the program counter. Okay, but what is the address stored in program counter? A set of instructions have been given here. Set of instructions have been given here. Okay, now LXI H, 8A79. Okay, what is LXI? Okay, LXI, if I just want to revise, all instructions are there at the end of PDF. Okay, when I share the PDF, all instructions are there at the end of PDF. Don't worry about that. Okay, LXI general nature is RP. Okay, comma a 16-bit number. Comma some 16-bit data. Okay, LXI RP comma 16-bit data. Okay, right. It will load the given 16-bit data into the register pair RP. Okay, RP. Okay, can be RP here stands for register pair. Okay, and RP can be B or C or D. Sorry, I'm so sorry. Okay, B, D, H for stack pointer, B for the register pair BC, D for the register pair DE, and H for the register pair HL. So these registers which I have put down in the same row, okay, they are set to form one register pair. Physically, they are two different 8-bit registers, but they are set to form a register pair. Okay, B and C combined. Similarly, D and E combined. Okay, and similarly H and L combined. These are known as register pair. One more thing that will come in that register pair is stack pointer. Okay, in that instruction LXI. Okay, in that particular instruction of LXI. So as and when required, some basic architecture, some basic theory I have included in the PDF, and again repeat, all instructions are included at the end of the PDF. At the end of the PDF. Okay, for your thorough revision. Okay, yeah. So from which address will the next instruction be fetched? From the address stored in the program counter. Okay, now see, what is the role of this LXI? Okay, LXI H, I told you LXI RP. Here RP taken is H. H is for HL. H is for HL. That means it will load into HL the given 16-bit number. Now 16-bit is in binary. We know that machine understands binary language, but actually in programming, to write down the programming in a shorter language, okay, we write down the hexadecimal number. In machine, it is stored in binary only. So what is this? 4-digit hexa is always 16-bit binary, because one digit of hexa is 4-bit of binary. Okay, So 8A79, H for hexa. Okay, now 8A79 means this much is in H and this much is in L. Okay, H and L. Okay, H and L. Now next, okay, move A comma L. This anyways you know. Okay, move instruction is always from second to first. Okay, that means it will copy the contents of L into accumulator. So what is there in the L? What is there in the L? 79. Copy into accumulator, please. Copy into accumulator, please. Now add H. Add H. Okay, what is add H? It is going to do A equal to A plus H. Add also we have seen earlier. Okay, H will be added with what? By default accumulator, result stored back in accumulator. Okay, result stored back in accumulator. That is 8A. Okay, what is there in accumulator? I'm sorry, accumulator now has 79. Plus what is there in the H register? 8A. What is there in the H register is 8A. Okay, so when I add this, okay, let me show you this addition separately. Okay, these are being added. Okay, these are being added. Okay, so what will happen? 8A plus 79. Okay, 8A plus 79. A plus 9. Now, what is A plus 9? Because D separately actually. H and DAA. Add H and DAA. Decimal adjust accumulator. Equal to A plus H. Now, what is there in A? Okay, A had 79 and there was in H the data that is equal to 8A. So 8A plus 79, they are required to be added here. Okay, they are required to be added. Okay, so when I'm going to add them, 8A plus 79, okay, A plus 9. Now A plus 9, remember it is a hexadecimal world, B, C, D, E, F. After F, 1, 0. Then 1, 1, 1, 2, 1, 3. Okay, these are the 9 digits. Okay, plus 9 I have to do. Now I repeat. After A, B, C, D, E, F. 1, 0, 1, 1, 1, 2, 1, 3. Okay, 1, 3. So result is 1, 3. 3 here, 1 goes here. Okay, now 8 plus 7 is F. Okay, 15 in decimal, but in hexadecimal it is F. Okay, F plus 1. F plus 1 is 1, 0. Okay, so 0 stored here and 1 is the final carry. 1 is the final carry. Auxiliary carry is also there. Okay. So after the add instruction, the result is 03, but okay, the result is 03, but DAA, whenever auxiliary carry, DAA instruction means whenever, this is known as decimal adjust accumulator. Okay, and what it does, okay, let me revise this also. It adds, okay, it adds 6 to the lower nibble. Okay, number 1 point you have to remember, it adds 6 to the lower nibble. Okay, if greater than 9, okay, or second auxiliary carry flag is set, and then it also adds, okay, 6 to the upper nibble, okay, upper hexadecimal digit, upper nibble, if, okay, if again first it is greater than 9 or second carry flag is set. Second if carry flag is set. Now see, okay, what is going to happen after DAA here? Okay, is the auxiliary carry flag, see, this is the result. Okay, is the lower nibble greater than 9? No. But is the auxiliary carry set? Yes, auxiliary carry is set. So we'll add 6 here. Okay, now see the higher nibble, upper nibble, is it greater than 9? No. But is the carry flag set? Yes, the carry flag is also set. To add 6 here also. Okay, 3 plus 6, 9, 0 plus 6 is 6. This is the result, okay, after DAA. After the DAA instruction. This is going to be the result after DAA instruction. Okay, so after addition instruction, what is the result I got was 03, and after DAA accumulator now gets 6 and 9. Okay, the explanation is shown backside. Okay, move H comma A. Now accumulator content copy to H. Okay, H will now have accumulator data, that is 6, 9. Now PCHL. What is PCHL? Okay, it will copy the HL contents to PC. Okay. HL to PC, second to first. Okay, second to first. So PC is equal to HL. Now what is there in H? H now has 6, 9. And what is there in L? Okay, L in between we have not fortified. So what was there in L in the beginning? 7, 9. It is still 7, 9. Okay, so because HL has 6, 9, 7, 9, PC will also have 6, 9, 7, 9. Okay, PC will also have 6979. So from which instruction, from which address the next instruction is fetched? Okay, from the address stored in program counter, and what is stored in program counter is 6979. Okay, this is a good question. Correct answer is C. Correct answer is C. Yeah. One small request, whenever you are mentioning the answer, please mention with the question number. Okay, because maybe it is the previous question answer or this question answer that you are telling, it will be a little bit clear for me. Okay, so please mention with the question number, like this is for 7, this is for 8, and etc. For this question, it is C. Okay, for this question, it turned out to be C. Any specific doubts, please mention here. Maybe it is the previous question answer or this question answer that you are telling. Okay, done. Let's move ahead to the next question. From which address will the next instruction be fetched? 6979. Okay, 6979. Acha. Now let me explain one more thing here with respect to this question. Okay. Which data instruction, Lucky? Which particular data instruction? Please tell me. Okay. Right. Okay. So now see here. Okay, let me explain you one more thing here. Like LXI H, 8 is 79, LXI RP, 16-bit data. Okay. 3-bit corresponds to 2 bytes. Okay. Now, if I just rewrite this instruction here, LXI RP, 16 instruction in memory in binary form. Okay, this is assembly language. This is mnemonics. Okay, this is mnemonics. Okay. Data instruction 2 means you are talking about this instruction, instruction number 2, which is move A, L. It will copy the contents of L to the accumulator. So that's what A will become equal to L. And what is there in N in L is 79. Okay. Now LXI RP, 16-bit data. Okay. So see, when the instruction is stored in machine in binary, okay, 16-bit corresponds to what? 16-bit corresponds to 2 bytes. To store the 16-bit data itself, I need 2 bytes. Okay, so one more byte is needed to store the opcode. One more byte is needed to store what? To store the opcode. Okay, to store the opcode. So total size of this instruction when it is required to be stored in memory is 3 bytes. Okay, it's a 3 bytes instruction, and that is why, okay, that is why you see here, okay, that is why you see here, okay, that if LXI is stored at the memory address 6010, okay, you will have to write down the next instruction after 3 locations, because this will require 3 locations. So what is 6010 plus 3? 6013. Okay, 6013. Now you see, this instruction has only mnemonics. Does it have any separate data? Okay, does it have any separate data? So if I want to write down one more example here, okay, after this DAA, see. Letters, only mnemonics, no separate data. So this entire instruction, okay, can be stored in 1 byte. Stored in 1 byte. There are some codes made for every register. That you don't have to remember. That is why I'm not going into it. Okay, right. There is a particular binary opcode for move. There is a 3-bit code for register A. There is a 3-bit code for register B. You don't have to remember that. Okay. But yeah, whenever the instruction has any letter, it is a 1 byte instruction. But if I write like, previously we have solved some question like ANI. Okay, ANI 54H. Now what is this 54? Okay, this 54 is a 2-digit hexa. It's actually a 8-bit data. In binary, it is the 8-bit data. And to store the 8-bit data, okay, 8-bit is equal to how many bytes? 8-bit is equal to 1 byte. 8-bit is equal to 1 byte. Okay, so if 1 byte is already consumed to store this data, 1 more byte will be required to store this opcode. Okay, so this instruction will become 2 bytes instruction. So in microprocessor 8085, you have total 3 types of instruction in terms of data. Okay, a 1 byte instruction, a 2 byte instruction, and a 3 byte instruction. Okay, a 1 byte or a 2 byte or a 3 byte. 1 byte instruction will store the opcode and operand. When the operands are only letters like register A, register C, register B. Okay, right. It will always store the opcode and operand in single byte. 2-byte instruction, okay, which will store opcode in 1 byte and the separate 8-bit data in the second byte. 3-byte instruction which will store the opcode in first byte and the 16-bit data, 16-bit data or address, whatever it is stored into 2 8-bit. Okay, one 8-bit is 1 byte. Okay, so then, okay, 2 more bytes, 2 more addresses. Okay, 2 more locations are required. Okay, very briefly I am telling about instruction word size. Okay, but you should be aware about it. Okay, you should be aware about it. Okay, right. I cannot go into very depth of everything right now since it's a question practice session, but relevant what is required at the end moment, that much I am revising. Any doubts you can separately mention. Okay, right. See, Lucky, this is what DAA will follow, na? And again, all instruction slides I will share it with you. Okay, you just have to check the lower nibble if it is greater than 9 or if auxiliary carry is let. If any one of this happen, add 6 to the lower nibble here. So this is not greater than 9, but auxiliary carry was let set, na, Lucky. Then see the upper nibble. If upper nibble is greater than 9, no. Okay. If carry flag is set, yes. Okay. If any of this thing happen, add 6 to the upper nibble. So here also I added 6. Okay. Here also I added 6. Clear, everybody? Okay. This is how I executed the DAA instruction. Okay. Next. This is instruction word size, which I explained to you right now. Question number 8. Okay, I will explain you about the buses, but tell me the answer first of all from your end. Tell me the answer from your end. Which bus is bidirectional? Address bus, data bus, control bus, or none of the above? Okay, the address bus, data bus, control bus, or none of the above? Okay. Yes, very good. So answers are data bus. Data bus is bidirectional. Okay. Now see, this is about the buses. Address bus. Okay, it is always unidirectional. Okay, from microprocessor, the microprocessor has just to inform the address. Okay, of the memory location or the input or output device from which it is interacting. The control bus. Okay, which normally sends control bus on a simple level you should remember. Okay, on a simple level you should remember. Control bus is responsible for 2 primary decisions. Number 1, whether the microprocessor is interacting with memory or whether it is interacting with input-output device. Number 2, okay, whether it is reading from the memory. Suppose it is interacting from memory. Okay, the data can be read from the memory or data can be written into the memory. So there are 2 types of operation, read or write. Okay, control bus sends the correct control operation, whether it is read or write operation, whether it is IO operation or memory operation. Control bus is also unidirectional. Okay, but data bus, okay, the data can be sent from microprocessor to memory or data can be bought from the data can be sent from microprocessor to memory, that is write cycle. The data can be read from memory to microprocessor, that is read cycle. Data bus is always bidirectional. Data can flow in 2 directions, from memory to from processor to memory or from memory to processor. But address bus and control bus are unidirectional. Okay, these are all the details that I have written here also. Okay, that I have written here also for your quick revision. Okay, like I told about control bus, it will normally carry the synchronization signal, identifies the device type, memory or IO, and dictates whether it is read operation or write operation. Okay, so which bus is bidirectional? Data bus. The address bus and control bus are unidirectional. Okay, that can also be a type of factual question for you. Okay, now, okay, look into this question. If the 8085 adds 87H and 79H, specify the status of the sign flag, zero flag and carry flag. Okay, flag based question. It is just nothing but a flag based question. Tell me the answer quickly. The 8085 adds 87 and 79. Okay, 87 and 79. Okay, what is the status of the sign flag, zero flag and carry flag? (87) and 79. Okay, so we just have to add it, a simple addition question. 7 plus 9, 9 plus 7, 16 in decimal, but we are in hexadecimal world. Okay, what is 9 plus 7? Okay, after 9 what will come? A. Okay, count that way. So A, B, C, D, E, F. 6 done, na? A, B, C, D, E, F. After F, 1, 0. After F, 1, 0. So 0 here, 1 here. Okay, now 8 plus 1, 9. 9 plus 7 is again 1, 0. So this is 0, this is 1. Okay, now see, What is the final result? Okay, in the accumulator is 0. So the 0 flag will be set. Is there a carry generated? Yes, finally there came a carry. Carry flag is 1. What is one more thing they are asking? Sign flag. Now sign flag, when you open this is binary. This is 0, 0, 0, 0, 0, 0, 0, 0. Okay, what is the MSB? MSB is 0. So sign flag is also 0. Sign flag is just copy of MSB actually. Okay, so what is the status? Sign flag 0, 0 flag 1, carry flag 1. Okay, what is the correct answer? A. It's not D, it's going to be A. It is going to be A. Option number A. Okay, option number A. Any doubts you can tell me. Okay, A. Some of you are telling D. Why D? 0 flag, why it is reset? 0 flag is set because the result in accumulator is 0, 0. This is carry. This cannot be stored. Accumulator can only store 8 bit. This is the 9th bit here. Accumulator cannot store 9th bit. Don't count this. The answer stored in accumulator is only 0, 0. The answer stored in accumulator, if you say 100, it is wrong. Understood? It is wrong. Okay. Next question. Number 10. Okay. Now be very smart in answering this question. Consider the 8085 program below, MVI A, BB. Okay, LXI B, 2060. Better it is little displaced. It is like this: MVI register A, comma data BB. This BB is an hexa. Okay. LXI I explained you already. LXI B, okay, comma 2060. Okay, hexa. Tags B. Okay. Right. After this problem is executed, the contents of accumulator and the flag which is set are. The contents of accumulator and the flag which is set are. Now see. Okay. Now see. Contents of accumulator and the flag which is set are. You can answer it very logically. I am telling you na. Okay. See, simple way of answering. You don't have to find even accumulator contents also. Why? Move, LXI stacks, all are what? All are data transfer instructions. And remember, data transfer instructions do not affect any flag. Okay, so answer has to be D. Okay, do not affect any flag, and that is only seen in the option number D. Data transfer instruction do not affect flag. Flags are affected by arithmetic or logical operations or rotate operation. Okay, but data transfer do not affect any flag. The data transfer instruction do not affect any flag. Okay, everybody. Okay, so simple question. Okay, if it was required, I would have calculated accumulator content, but not required. Leave it. Okay, that is how smartly you have to play in the exam if you are able to match the answer. Okay, but yeah, in some later question, whenever required, I can explain you LDA, STA or LDAX or STAX. Okay, right now let's go to the 11th question. Okay, the contents of accumulator of 8085 microprocessor after the execution of following instruction will be how much? Will be how much? Now see. Okay, what is the first instruction here? MVI A, A7. Move immediate. Move this data A7. A7H means A7 in hexa into the accumulator. Then ORA. Or. Okay, or with what? By default, one of the operand is accumulator. And this is also accumulator specified. Okay, and the result is also stored in accumulator. A is equal to A or A. When you do the same XOR same, bit by bit only you will do. But suppose if the bit is X. Okay, what is X plus X? It remains to be X. Okay, 0 plus 0 will remain 0. 1 plus 1 is also 1. Basic Boolean laws. Okay, 0 plus 0 is 0. 1 plus 1 is going to be 1. So A or A will be A only. If it does not change the content of accumulator, why this instruction is used? Okay, to activate the flag ORA. Okay, I told you all logical operation and or XOR. They will reset the carry flag. Reset the carry flag. I told you na, whether it is OR, whether it is AND, whether it is XOR, all of them will reset the carry flag. All of them will reset the carry flag. Now, what is this instruction RLC? okay, this instruction RLC, okay, is rotate accumulator left without carry. Now there is a sort of confusion in microprocessor 8085. Okay, and wherever RLC is there, okay, and if it was RAL, I'll tell you the confusion. Okay, RAL. Okay, RAL where C is not written. Okay, the instruction is actually rotate accumulator left. Okay, with carry. Rotate accumulator left with carry. I will explain you both with respect to this example. Okay, so there is a sort of confusion. Now, why this is the confusion, we don't know. Okay, this already has been designed and hardwired by Intel long back. It's one of the oldest microprocessor 8085 we are talking about. Okay, but yeah, definitely there is a confusion in name where the instruction RLC, where they use the letter C, it is without carry, and where the letter C is not used, rotate accumulator left. Okay, but that is with carry. Now, what is the difference in both the operation? I'll explain you. What is there inside the accumulator? A. Okay, that is A7. A7. Okay. Accumulator has the data A7 and A means what? Okay. A is 1010 and 7 means 0111, correct? That is A. Okay, A 1010 and 7 means 0111. Okay, this is what it is, correct? A equal to A7, 1010 and 0111. Okay, A. Now, okay, now, okay, right, 1010, 0111. Now, if it is RLC, okay, acha, what is the status of the carry flag? Carry flag is reset. Okay, and we have to do rotate left. Okay, so see, 1010, 0111. Here, 1010, 0111. And what is the carry flag? This is accumulator. And what is the carry flag right now is reset. Okay, but if I am going to do RAL, okay, or let me do RLC, that is the question. Question is actually asking RLC, na? Rotate accumulator left without carry. Okay, that means, see, every bit will rotate left. Okay, this will going to affect the carry flag. This will affect the carry flag, but carry will not be rotated with the data. Carry will not come up here. What will come up here? Because you're rotating left, sorry, this will come up here. Okay, this comes up here, this comes up here, like that. Okay, this 0 comes up here, this 1 will come up here, this 1 comes up here, this 1 comes up here, and whatever was the MSB bit, na, this MSB bit will go here. Cyclically it will rotate, okay, in a circular manner, and this will be 1 here. Okay, this will be 1 here. Understood? Okay, so see, this 01001111, 01001111 as it is. Okay, this 1 goes to the LSB. Okay, now what is the answer in hexa? Okay, what is the answer in hexa? After this instruction, accumulator now contains, what is this? 4, 0100 is 4 and 1111 is F, and the carry flag is set. And the carry flag is set. Okay, so our final answer is 4F. Final answer is 4F, answer is B. Okay, answer is B. But if it was RAL, let me explain you that also. If it was RAL, okay, if it was RAL, then how will you deal? Okay, so see, same accumulator contents I will take here. Okay, that is 1010, 1010 and 0111 and the carry flag which is equal to 0. Okay, now when I say RAL, what did I say about RAL? Rotate accumulator left with carry. Okay, that means carry is taken, okay, as a part of data. In a way, assume this as a 9-bit number and do the rotation on the 9-bit number. So this 1 will come up here, but this carry will go here, okay, to the LSB. Earlier what happened? See the difference. Earlier, okay, this MSB goes to the LSB, but now this carry will go to the LSB. So you have to just assume the whole data as a 9-bit number, okay, and do the rotate operation. This 1 comes up here, then this is 0100 0100 okay, so now what is going to be the answer? This is 4, this is 4 again, and this is E. The answer will be 4E. In that case, the answer will be 4E. Correct, Lucky. If it is RAL, the answer will be 4E. If it is RLC, the answer is 4F. Okay, the answer is 4F. Done. Next question. Yeah. Now, this is purely, based out of data transfer instruction. Let's have some XOR operation into it. The following program is written for 8085 microprocessor to add 2 bytes located at the memory address 1FFE and 1FFF. Okay, 1FFE and 1FFF. Okay. Now see here, I'll explain you, okay, this M. With this question, okay, the M will come. M, memory pointer. Okay, let me talk about this M. Of memory pointer. Okay, M will normally play the role of memory pointer. What is the role of memory pointer? It will play the role of memory pointer. Okay, it will play the role of which memory pointer? It will point to which memory location specified by register pair. Specified by HL register pair. Now understand this. Okay, understand this with respect to this example. Okay, LXI H comma 1 triple F. LXI I have already explained you. Okay, load register pair. Okay, which register pair? H is for HL actually. H is for HL. So HL will store this data 1FFF. Okay, now move B comma M. You know the nature of move second to first. Okay, second to first. So this instruction, okay, will copy the contents of memory location into B. B will not be equal to M. B will get the data from the memory location M. Okay, now the story is something like this. Okay, suppose the memory array is there. Okay, suppose this is 1FFE. This is 1FFF. Okay, after FFF 2000, after 1 triple F, like after 1 triple line 2000 comes in decimal, in hexadecimal it is 2000 after 1 triple F. Okay, now see what is going to happen in this instruction. Okay, suppose this 1 E has some data. Okay, I will call it as some, data number 1. Okay, move B comma M, as I told you, it will copy the contents of the memory location. Which memory location? Which memory location? Okay, whose address is specified by HL register pair. So you have to see what is the stored in HL register pair, 1 triple F. So microprocessor, whatever is stored in HL, microprocessor will go to that address. Okay, take the data from there and copy into the register, copy into the specified register. So B will get this data number 1. Okay. Then INRL. Okay, INR is increment. Okay, increment the contents of register L. Okay, so L has to be becoming L plus 1. Okay, L plus 1. Now, what will be L plus 1? What was L? FF plus 1. Plus 1 means plus 0, 1. Increment by 1. Okay, and FF plus 0, 1 is how much, dear? What is FF plus 0, 1? Okay, as a 2-digit hexa number. What comes after F is 1, 0. So 0 here, 1 here. Again, it is F plus 1. Okay, what comes after F? F plus 1, 0, carry 1. Okay, this will affect the carry flag, but the result, the 2-digit hexadecimal number, okay, or a 8-bit binary number will be 0, 0. Okay, L will now become 0, 0. Right? Right. L will now become 0, 0. No, there is a typo error in the question. The question says that it has to add 2 bytes of number stored at the memory location 1FFE. Okay, so guys, there is a small error here. This is 1FFE actually. Yeah, this is 1FFE. So HL initially is 1FFE. Okay, so that is what it will go to this location 1FFE and copy the data into B. Now, when you increment, okay, this is not required. Okay, this would be required maybe later on. Yeah. Okay, so now it is going to increment L by 1. Okay, what is the L content? FE plus 0, 1. E plus 1 will be F. So the answer will be FF. Okay, now L contains FF. Okay, it will now go to the next instruction, move A comma M. Okay, move A comma M. What will this instruction do? It will again copy the contents of memory location. Copy the contents of memory location into accumulator. Which memory location? okay, whose address is specified by HL register pair. So now what is in HL? H had 1F, but L was incremented. L is now FF. So total address now is 1FFF. And suppose there is some another data 2 stored here. So data 2 will come up here. Understood? Because I got FF. We want FF. So HL overall is 1FFF. Okay, 1FFF. So microprocessor will go to this particular address, whatever is the data, suppose data 2, it will copy into the specified register, which is accumulator here. Now add B, we all know how add will execute. Okay, it will add A plus B. Okay, it will add A plus B. Okay, right. That is what was required to be done. What is A? A has the data number 2. Register B, okay, register B has the data number 1. So both these data will be added. Now again INR L. Okay, now again L is L plus 1. But what is the L data now? FF. Okay, when you increment FF by 0, 1, it is now going to become 0, 0. It is now going to become 0, 0. Okay. It is now going to become 0, 0. L is 0, 0. But what is HL? What is HL? H is 1F. There is no change in H. This is H, this is L. Okay. H is 1F and L becomes 0, 0. Now, reverse, move A comma M, reverse from accumulator to the memory location. Okay. So, contents of memory location will now be equal to the, okay, contents of accumulator. Okay. And what is the content of accumulator? Addition of the 2 bytes. Okay. Right, XRA, that will just clear the accumulator. See, final question, on completion of execution, where is the result of addition found? Okay, accumulator contains the result of addition. Accumulator contains the result of addition, and that is now copied into which memory location? Okay, into the memory location 1F00. Okay, answer has to be C. Okay. The result of addition goes into which memory location? Okay, 1F00. Okay, the content of 1F00 will be equal to accumulator, that is equal to the result of addition. Okay, that is the result of addition, option number C. This is a good program out of data transfer instruction. This is a good program out of the data transfer instruction. Okay, out of data transfer instruction. Okay. Okay, right. Then tell me any doubts in this program. Next question. Let's go to the next question here. Yeah, in 8085 microprocessor, the contents of accumulator, okay, after the following instructions are executed will become how much? Okay, please solve this carefully and let me know. Please solve this carefully and let me know. Yeah. Okay. So let's check it out now. Okay. In 8085 microprocessor, the contents of accumulator after the following instructions are executed will become how much? Answers have started coming up. 13th answer is coming up as C by some of you. Okay, Rutvik, Lucky, Praveen Kumar. Okay, see here. XOR A. A is equal to A XOR A, and this I told you earlier also. Okay, same XOR same will always be 0. Okay, this is just to clear the contents of accumulator to activate the flags also. Okay, now MVI B comma F0. Okay, MVI B comma F0. Okay, it will copy the immediate data F0 into the register B. That also okay. Okay, now sub B. Okay, what is the role of this instruction? Sub B. Okay, it will subtract the contents of B from where? From by default accumulator. Okay, A equal to A minus B, but what is there in accumulator? Accumulator is cleared. It is 0. Okay, now 0 minus B. Okay, 0 minus anything. 0 minus X is like minus X, no? It is minus B. But remember how a negative number is stored. This is actually a concept of digital that you have to apply here. Okay, how a negative number is stored in the machine. Okay, by taking the 2's complement. Okay, so this is actually equal to this is like a 2's complement problem. 2's complement of B, or you can do the 16's complement of B if you are dealing in hexa. I told you now both are equal. In binary, if you expand in binary, do the 2's complement, or otherwise you can do the 16's complement. Okay, so what is going to be the 16's complement answer? Now see, what is there inside the register B? Okay, F0. How do you take the 16's complement? First, you will take the 15's complement. You will subtract every digit by FF. You will take the F's complement. So F minus 0 is F, and F minus F is 0. Is it not the case? Okay, F minus 0 and F minus F. Okay, now plus 1. Okay, 15's complement, R minus complements plus 1 to the rightmost digit will give R's complement. F plus 1, 0. Carry 1. 1 plus 0, 1. Answer is 1, 0. D is the answer, not C. D is the answer. D is the answer. Okay, guys, many of you have given C. How it is C? Okay, it is not addition, it is subtraction. How 0 minus F0, okay, can be F0? Okay, how suppose if I write down in decimal also, how 0 minus 5 is 5? It has to be minus 5, na? Okay, if you are telling C, what you are trying to tell me is 0 minus F naught is again F naught. How it is possible? That is wrong, na? Okay, that is wrong. 1, 0. The correct answer is actually D, that is equal to 1, 0. Okay, dear? No, it won't be same. Okay, Praveen Kumar, no. Right. The answer would be D, 1, 0. Got it, everybody? Okay. Okay. Right, that is an important concept. So have a look into this similar question. Okay, no, this is not that one. Yeah, these are very, let me check. No, this is a different question. The contents of register B and accumulator are given to you. Okay, the contents of A and the status of carry flag and sign flag after executing sub B instruction. Okay, yeah, similar concept. Now you have to tell me, okay, how are you going to deal with this particular question? Okay. Some questions will be basic arithmetic question. Only basic instruction you have to know. Only one instruction. Okay. After executing sub B instruction. Okay. See, what is the data they have given? Okay. The contents of register B is 49. B contains 49 in hexa only. Accumulator contains what data? Accumulator contains 38. Okay. And then there is the command sub B. Okay. You know that what is sub B. Okay. A equal to that is 3A minus 49. 3A minus 49. Now, how are you going to solve this? Let me know. Okay, 3a minus 49. How will you solve this? Okay, 3a minus 49. How are you going to solve it? Okay. Okay. What is the question finally? Accumulator data also required, carry flag and sign flag. Three things are required here. Okay. 3a minus 49. Let's do it. Okay. 3a minus 49. This is the question here. B is 49. Okay. And accumulator is 3a. 3a minus 49. Now see here. I will subtract a minus 9. Okay. A minus 9, 2. Okay. That part is okay. Okay. A minus 9 is 2. But can you now write down the final answer? Acha, tell me whether the final answer will be positive or negative. Whether the final answer will be positive or negative. If that is what we can rectify. 3 minus 4. Okay, 3 is less than 4. Okay, 3 is less than 4. Okay, so final answer will be negative. Okay, and 3 is less than 4, that means borrow will be required. I will always suggest rather than you go for borrow, okay, because again you will have to adjust the answer, do one small thing. Okay, rather than you go for borrow cycle. Okay. Shall I write it this way? 3a minus 49 is 3a plus minus of 49. 3a plus minus of 49. Okay. Or you can do the reverse, subtraction and write down the answer. Okay. 3a plus minus 49. Let's do it this way. Now, what is minus 49? I explained you with the previous question. Minus 49, okay, will be obtained by taking the 16's complement. First, I will take the 15's complement. What is f minus 9? Is 6. Correct. And f minus 4 will be how much? B. Okay. C, D, E, F. Correct. Okay. This is to be added with 1. So, this is B7. Okay. So, minus 49, I will treat it as B7. Now, see here. Okay. Now, see what is the answer. Okay. B7 and 3A. 3A, B7. A plus 7. Okay. Go A plus 7. What will you get? B, C. 7 places ahead I will go. B, C, D, E, F, 1011. I repeat. B, C, D, E, F, 1011. 1011. This is 1, 1. So 1 will be the carry. Now B plus 3 plus 1. So B plus 4. C, D, E, F. C, D, E, F. F. So answer has to be F1. Answer has to be F1. Right. So answer is F1. Okay. Now F1, as I told you, answer would be negative. And see here, when you expand this in binary, 1, 1, 1, 1, 0, 0, 0, 1. Okay. So sign flag will be set. Because MSB is 1, so sign flag will be 1. Okay. Sign flag is 1, and what is the result of accumulator? Is F1. Okay, the result is F1. Okay, not F0 or 1F, and sign flag is 1. Okay, now why carry flag is set? Okay, see in this actual thing, why carry flag is actually set. Okay, carry flag is set whenever there is a borrow required, because there is no separate borrow flag. Okay, simply remember the point that 3A, okay, is less than 49, and because 3a is less than 49, so borrow required, and there is no in the sign flag only. Sorry, it is indicated in the carry flag only. Okay, it is indicated as carry flag, and that is why carry flag has to be 1. Okay, so F1, okay, carry flag 1, sign flag 1. Okay, option number A. Okay, option number A. Okay, option number A. That is how you will complete this. Okay, any doubts here? Please mention it to me. Okay, basic arithmetic question. Okay, now see next question. PCHL I explained. DAD instruction is now coming. Okay, DAD. Okay, DAD, double addition direct. It's a simple question if you know the DAD. Let's revise that. DAD stands for double addition direct. Double means addition of 16-bit numbers. Okay, so DAD RP, it will add the contents of register pair RP with that of HL. By default, one of the operand here is HL, and the result is also stored in HL. The result is also stored in HL. Okay, so it will perform HL plus RC, RP, and result is stored in HL. RP can be any specified register pair. Here it is H only. Okay, so what is the role of this DAD H? Okay, HL will be equal to HL plus R plus the same HL. Okay, H for HL you know, na? Okay, so what is there in HL? You see the command LXI H comma 3080. It will load HL equal to 3080. It will load the HL equal to 3080. Okay, so 3080, I will add here. Okay, plus 3080, okay, will be how much? Okay, 0 plus 0 is 0. What is A plus A? Okay, if I count on fingertips, A is 10. The A value is 10. So 10 units ahead. B, C, D, E, F, 10, 11, 12, 13, 14. 14. I will stop at 4. Okay, and 1 will go to carry. 1 plus 0 is 1. 3 plus 3 is 4. Okay, so after DAD 6140. Okay, 6140. PCHL. Okay, we have taken in the previous question also PCHL, HL to PC. Program counter will get the data from HL and that is 6140. That is 6140. Okay. So all addresses and constants are in hexadecimal, that is okay. Let PC be the contents of program counter, HL be the contents of HL register pair after executing PCHL. Which of the following is correct? Okay, so after PCHL, PC will get HL. HL anyways has 6140. So both will have what answer? Both will have the data 6140. Both will have the data 6140. PC and HL. Both will contain the data 6140. Okay, 6140. Next. Okay, any doubts here? Basic program here, basic program. Okay. Okay, now see what is this next question? The contents of HL register pair after the execution of the following program. Now see here. Okay, let's say 2095. Okay, load register pair immediate. Okay, HL register pair will get the data 2095. Okay, this one will be H, this one will be L. Okay, then LXI B. Okay, same command LXI but on B. B for BC. In terms of register pair, B is BC. Okay, that will get the data 8FBF. Correct na? 8FBF. This will be B. This will be C. Okay. Push B. Now push and pop, stack based instruction. Push and pop and XTHL. I'll explain you STHL also. Okay, I'll explain you directly with the flow actually. It will be easy for me also. I think it has. No problem. Just let me come up here. XTHL. Okay. Now see push. Okay. First of all, wherever is the stack pointer is not given. Okay, stack pointer value is not given. Okay, but stack pointer is the 16-bit memory the top of the stack. Okay, now for example, let's say stack pointer contains the data 2000. Okay, suppose this is 2000. Okay, this is what is right now TOS. TOS, I told you what? Top of stack. Okay. Now, if this is the stack pointer and whenever push instruction will come, the storage of data byte, okay, occurs in the reverse numerical order. Okay, reverse. Okay, so I will explain you as a point. Suppose this is the memory address 00. This is the memory address. I write FFFF. Okay, right. The starting address in 16-bit is 0000. The ending address in 1111. FFFF. I mean all ones, all 16 ones. Whenever push will come, what will happen? Now see, push B. Okay, let's understand push B here. Okay, when push B will come, okay, B stands for what? B stands for BC. Okay, firstly the stack pointer will be decremented by 1. Okay, and it will become 1FFF. Don't say 199. Don't say 199 because it is hexadecimal. It should be 1FFF. And the high order register B will be copied here. Okay. And it is again decremented by 1. Then it becomes 1FFE and then the lower order register. I repeat, stack pointer is first decremented by 1. Nothing will be stored here. It is already top of stack. Okay. Some data might be here. That's what I'm assuming. Suppose you are creating a pile of books. Okay. right? You are storing some books, okay, physically, pile of books, okay, at the top one book is already there. If you have to place two more books, okay, or if you have to place the next book, it will go above this, na? Same thing is followed with a stack. Stack is also like a LIFO structure, LIFO, last in, first out. Okay, so it keeps on growing, and when I want to take the book out, okay, whatever the top book, that will be retrieved first of all. Okay, so see here, this B goes here and this C goes here. Higher order register, then the lower order register. Okay, then there is the command XTHL. Okay, and then there is the command POPH. XTHL will exchange the, this is to exchange, okay, the HL data, okay, HL register pair data, okay, with, okay, top two, okay, stack data, with the top two stack data. Okay, so when I talk about XTHL, okay, this will be copied to L, this is going to be swapped with H. Okay, right. Now what is in H before the XTHL? 2095. That means, okay, after this, the data of L, okay, that is okay, and from C, and what is the data in C? What is the data in C? BF. That is equal to BF. Okay, here. Okay, now the data from B swap. Okay, so what is the data in H? 20. What is the data in B? That will go to H. Step. Okay. This is 8F. This is going to be 8F. Okay. This is going to be 8F. This is how it is going to be executed. After XTHL, this is what is content. Now pop H. What is the meaning of pop H? Okay. Pop means retrieving the data from the stack. Okay. In the reverse order. Okay. Now, okay. What was stored in the stack? Okay. B and C. Okay. But now after exchange operation, okay. If I recreate this picture, okay. If I recreate this picture, after the exchange operation, memory address 0000, this was 1, this is 1 triple F, and this is 2000. Okay, currently my stack pointer was here. Okay, now I'm going to explain you the pop cycle. Okay, what is the data here now? Okay, what is the data here now? Okay, data which was stored as B, but that was exchanged to H and 20. So 20 pop H. Okay, now pop H. Okay, what is the meaning of pop H? Okay, so now when I'll write it here. Now when I'm going to explain you pop, this data, pop is into what? Pop is pop H, I think. Pop H. Okay, H for HL. It will work reverse of push. It will actually work reverse of push. Reverse of push means, okay, first the content of the top of stack is copied into lower order register, stack pointer incremented by 1. Then this goes to the higher order register, stack pointer again incremented by 1. That means L will get 95, H will get 20. Okay, the question is, what is the contents of XL? What is the content of HL register pair only? And that is 2095. Okay, that is 2095. Okay, that is 2095. Push was push B, na? Yeah, correct. Okay. Initially, I had the data here. What was B data? Okay, I'll write down with more clarity. B data. Okay, that is what I have written here. 95 here and 20. And you are popping it into H only. So H data is, okay, same, 2095. H data remains to be 2095. Option B. Okay, 2095. Consider the following 8085 microprocessor program. Okay, and tell me the answer. Okay. Tell me the answer now. Consider the following 8085 microprocessor program and tell me the answer. Okay. MVI A comma data 1 given as A7. Now some conditional jump instruction. Okay. A is equal to data 1 and data 1 means A7. Okay. Data 1 means A7. Okay. ORA A. Okay. A is equal to A or A, and or X plus X is same as X, so it will remain as A only. Okay. A means A7. Now, what is this instruction? Okay, JM. This instruction is known as jump on minus, a conditional jump instruction. Jump on minus means what? Okay, similar to JM, there is a JP. I will write down both. JP instruction is known as jump on plus. Jump on plus. Jump on minus, jump on plus. So, what is jump on minus? What is this instruction jump on minus? Okay, jump on minus. Okay, if the result is a negative number, okay, if the result is a minus number, then only you have to jump, otherwise you don't have to jump. So see, MSB, is this a negative number? Yes. Is this a negative number? Yes. So will the jump happen? Yes. Jump where? Jump to this label. Okay, jump to this label. So after this, it will directly go here and then add 0, 1. Okay, sorry. There is a problem. This is wrongly written. Okay, I will rewrite it here. There is a problem. This display has to be here. There is some typoing issue, I think. This display had to be here, not here. Not here, not here, not here. Sorry. Now see here. Okay, so where I will jump to this display. Now what is this? CMA. Okay, what is this CMA? Complement the contents of accumulator. Complement the contents of accumulator. Okay, and then ADI 01. Complement means what? Once complement and then add 1. Okay, so after one's complement, okay, we can do F's complement directly. FF minus A7. F minus 7 is 8 and F minus A is equal to how much? That will be 5. Okay, that is going to be 5. Okay, out to the port 1. This is out, not OT. OUT, out to the port 1. Okay, so what is the output at port 1? Okay, the output at port 1 will be the contents of accumulator, and that is equal to 59. The answer for the question is 59. Answer is D. Okay, when you add 1 here, okay, 59. Okay, right, 59. Complement directly. FF minus A. Okay, I've again tried checking the mic settings again. Let me see if it works out. I know the voice issue had been there, but on the spot we didn't have any solution. That is why I asked you to manage for this one. Okay, so what is the output at port 1? Okay, it is going to be 59. The output at port 1 is going to be 59. Okay. Now see the. Okay. Now see, by chance if it was plus number, then it will not jump. I told you jump on minus. Okay. That means if it was positive number, it will directly send a number to the port 1. Okay. Output to the port 1. Okay. So that means what this program is doing for you. If it's a positive number, send it directly to the port 1. Send it at output to the port 1 to some output device. If it is a negative number, takes the 2's complement and then send it. Okay. Because 1's complement plus 1. Okay. But 2's complement of the number. Okay. Next question. Okay. Again a programming based out of a jump instruction. Again a program based out of but 2's complement of the number. Okay. Next question. Okay. Again a programming based. Okay. No, Lucky. A7 is not positive number. In a 2, it is not a positive number. Okay. Yeah. Let's go to the next question. Have a look into this next question. This is the assembly language program MVI B, 87 move A, B, JMP next, etc. Some set of the program is given. The execution of our program. Now see, whenever you see this instruction, there are two instructions, two jump instruction in this question. Okay, this is JMP. JMP is unconditional jump. Unconditional jump. Okay, jump without thinking anything. Okay, without thinking anything, jump. And what is this? Another instruction that you have here is JP. Okay, JP means jump on plus, as I told you with the previous question. JP means jump on plus. Okay, JP means the jump on plus. Okay. Okay, so MVI B, 87, the register B will get the data 87. Okay, move A, B. A will get the data from B and that is equal to 87. Okay. Now jump means unconditional. Always you have to jump. Always you have to jump only. So jump here. Okay, jump to this label next. Okay, next. Now XOR A B. XOR A B. Now A is equal to A XOR with B. A is equal to A XOR with B. Okay, but A and B both have the same number right now. 87 XOR 87. Okay, so the answer is 0 0. The answer is what? 0 0. Same XOR same is 0, na? Okay. Now 0 0, if you open in binary, okay, is all 0, and now the sign bit is 0. That means it's a plus number. Okay, so jump on plus. If it is plus, please jump. So yes, it is plus. Yes, it is plus. MSB 0 means it is plus. So jump on plus to start. Okay, jump on plus to where? To start. Okay, jump here. Okay. Now jump here means again, you know, where do you go? Start, which again says JMP next. So these instructions are like looking meaningless. Okay, again jump here. Okay, now again jump to next. Okay, now do XOR AB again. Now when you do XOR AB again, it is again A equal to A XOR B. XOR AB na, A XOR B. Okay, but A contents were modified. A contents were modified as 0 0. Okay, XOR with the register B. What is the register B data? That is 87. And now this time it will be 87. Okay. Basic XOR properties. Okay. What I am telling, X XOR X. Same XOR same will be 0 only. But X XOR 0. Okay, will always be X. Anything when you XOR with 0, it is unchanged. Okay. So 87 XOR 0 0 will be 87. And what is 87? 8 is 1 triple 0. 7 is 0 triple 1. Now this time you see. The number is a minus number. Because MSB, the number is a minus number. So will the jump now happen? Will the jump now happen? Now it will not jump. Okay, so it will directly go here because it will only jump if it was a plus number. It will only jump if it was a plus number, but it is a minus number. It will not jump and it will directly send the data to the output device. Which data? Accumulator data. So what is the accumulator content now? 87. Okay. So after the execution of our program, what will happen? An output of 87 will come at which address? At 4. Okay. Output of 87 will come at port 2. Okay, what will go at port 2? Accumulator data, and accumulator data was 87. So you will see an output of 87 at the output device connected at the port 2. Okay. Now you can tell me if there is any doubt. Minus number. Because MSB, the number is a minus number. So will the jump now happen? A contains this plus to jump. AP was incremented. L is now. Question number 19 now. An Intel 8085 processor is executing the program given below. And the number of times NOP. NOP means no operation. It will not do anything. It will just into because microprocessor has to still read the instruction, and after reading the instruction, it will understand that nothing to be done. Okay, that is what NOP. Okay, that is what NOP. No operation. Okay, not to do any operation. NOP. Okay, it stands for no operation basically. Okay, NOP is a type of command which stands for no operation. Microprocessor will not do anything whenever this instruction is encountered. Whenever this instruction is encountered. Okay, the MVI A comma 10. Okay, A will get the data 10. MVI B also 10. Achha, this is I think missed out. It is A only as far as I remember. B will get the data 10. Now do nothing. Okay, but now add B. Add B means what? A equal to A plus B. Okay, 10 plus 10 will become 20. Okay, 0, 0, 0, 1 plus 1 will become 2. Now RLC. Okay, rotate left without carry. C is coming in the instruction means you have to rotate without carry. Okay, now see here. The rotate I will have to explain it separately. What is the content in accumulator? 20. 0, 0, 1, 0, 0, 0, 0, 0. Okay, now rotate left. Okay, when you do rotate left, okay, when you do the rotate left, what will happen? Without carry. Okay, this is without carry. So even if you don't write down carry, it's not a problem for me. Okay, so this is going to become, just rotate left, 0, 1, 0. Okay, and then 0, 0, 0, 0. And this MSB goes here to the LSB, 0. Okay, 4 and 0. This becomes 4 and 0. Okay, so after RLC, accumulator will now get the data 40. Now JNP, jump on no carry. No, I will have to write carry because there is again a jump instruction. Jump on no carry. Okay, jump on no carry. Okay, there is an instruction, jump on no carry. Okay, so I will have to write down the carry cycle also. Okay, so yeah, I will write it here. Okay. Whatever is this data, MSB, that will go to carry also, and that will go to the LSB also. Now, is there no carry? Yes, because the final result is 40. Okay, and the carry flag is reset. Okay, jump on no carry. Okay, jump on no carry means jump if the carry flag is reset, if the carry flag is 0. So yes, carry flag is 0. Jump on no carry to where? Jump on no carry to back. Jump on no carry to this instruction known as back. Okay, where? Here. Okay, again do NOP. Achha, question is how many times NOP is executed? Okay, already it was encountered one time. I have come one more time here. Okay, the number of times I come here, I will keep marking here. Okay, so one more time. Now again add B. Okay, now what is going to happen? One more time. A equal to A plus B. B has the data 10, but A has the data 40. Okay, so 40 plus 10 now. Okay, 40 plus 10, 50. And now again do R. Again, I will see with the data. Okay, now the data is 50. 5 is 0101. Okay, earlier the data was 20. Okay, now the data is 50. Okay, 5 is 0101 0000. Okay, and the carry flag. What was the carry flag before this? 0. Okay, the carry flag was 0. This will again go to carry flag. It will be 0 only. Then 1010 1010 000, and also this 0 will go here also. Okay, so what is the contents now? 8 and this much is 0. Okay, so after one more RLC execution, okay, accumulator now contains the data A0 and carry flag is still reset. If carry flag is reset, okay, if carry flag is 0, you have to jump again. Okay, you have to jump again to back. So one more time I come to NOP. One more time I come to NOP. Third time I come to NOP. Now again add B will happen. A is equal to A plus B. Accumulator data is now A0 after rotate plus B data. That is 10. So this will become A plus 1 is B. So this is B0. Now I will again execute rotate operation on B. Once again I will execute rotate operation on B0 data. What is B0? B is 1011 and 0 is 0000. Okay. Now carry. This time this will go to carry and the data is 011 0110 000. Also this MSB will go to LSB. This is 1. So this time it is 6 and 1. 6 and 1 carry flag set. Okay. So after third rotate, okay, accumulator data becomes 6-1 and carry flag is set. Now because carry flag is set, don't jump. Because the carry flag is set, now don't jump. Okay, now don't jump means, okay, go to the next instruction. Okay, that is halt. Okay, the program halts. And how many times NOP got executed? How many times NOP got executed? 3 times. Tell me any doubt. How many times the NOP got executed is 3 times. Okay, 3 times. How many times the NOP? Okay, guys. 3 questions and we keep giving you as homework because audio is not supporting. Okay, so it has been disturbing since the beginning only. But again, one more jump based question as homework. Okay, this is J and Z. Okay, jump on no 0. Okay, that means jump if the 0 flag is reset. If the result is non-zero, that means if the 0 flag is reset. One more question on jump. One more question on jump instruction. And another one more question. Okay, the number of times a loop is executed, and this is again J and Z. Okay, jump on no 0. Okay, so please, these are 2 homeworks for you. These are 2 homeworks for you. Now see a very basic question. Let me take you towards 2-3 more different questions here. Okay. Any doubts in the homework question? Please feel free to message me in Telegram. Okay. The clock frequency of 8085 microprocessor is 5 megahertz. The time required to execute an instruction, the number of T states. Now see, a very basic concept. The time required to execute an instruction is equal to number of T states of that instruction, okay, multiplied by the time period of the Now what they have given, the time required is 1.4 microseconds. Okay, 1.4 microseconds, 1.4 10 power minus 6 is equal to number of T states, suppose n, into time period of the clock. What is the time period of the clock? Okay, 1 upon, what is time period? 1 upon clock frequency. Clock frequency. And what is the clock frequency? 5 megahertz. Okay, 5 into 10. 6 will cancel. The answer is 7. Okay. The time required for execution of any instruction is number of T states multiplied by clock period, multiplied by the clock time period. This you can remember. Okay. What is one more basic question that can be expected for you? The starting location of a 4 kilobyte memory is 2180. What is the final location? Okay, starting location of a 4 kilobyte memory is 2180. 4 kilobyte means how many actually memory locations? Okay, what is 4 kilobytes? What is 4 kilobytes? Accordingly, you have to answer. And what is its value in hexa? Okay, because this is given in hexa. 4 kilobytes. Okay, and what is kilo? Kilo is 2 power 10. Okay, 1K in binary world is 2 power 10. Okay, 2 power 10, which is 1024. Okay, 1K, like in normal SI units, it is 1000, but in the binary world, 1024 is the only nearest power of 2. Okay, because we all deal with the 2 power calculation. So 1024 is taken as 1K here. Okay, so 4 means, okay, 4 into 2 power 10, okay, that is equal to 4096. Okay, or I can simply write it as 2 power 12 actually. Better to write it as 2 power 12. Okay. Now simply remember, this is 2 power 12. What is its binary value? One simple technique I will tell you. Okay, whenever you want to write down 2 power n into binary, suppose 2 power n is a decimal number, you want to write it in binary. Simple law. Okay, simple technique. Write 1 followed by n zeros. Write 1 followed by n zeros. This is the binary equivalent. 1 followed by n zeros. Okay, suppose if I ask you 2 power 4, which is 16. I hope 16 you can directly also remember. What is 16 binary value? 1 and 4 zeros, right? Suppose if I take 2 power 3, example 8. What is 8? 1,000,000, 3 zeros because it is 2 power 3. Understood? It's a simple logical technique. So 2 power 12 in binary will be 1 and followed by 12 zeros. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Total 12 zeros. This can be further written as, okay, this 1 I am writing 0001. Before a number, any number of zeros you can add. Okay, then 0000000000000. Okay, this is 0, this is 0, this is 0, this is 1, this is 1,000,000. Okay, in hexa. This is 1,000,000 in hexa. Okay. Now, the total number of memory addresses is 1,000,000. The starting address is 2180. What is the final location? Final location is starting 2180 plus number of addresses, that is 1000 in hexa, and minus 1. Okay, and minus 1. Because you are counting already 2180 is there. Okay. If you are counting 1000, the final location, this is the first location. Okay, I'm not telling that 2181 is the first location. So since it is already counted, you have to subtract 1 here. Okay, if you have to, suppose understand in a simple way. I am right now at some house address. Understand house address rather than memory address. I am right now at some house address which is equal to, suppose, 65. Okay, and the street has 4 houses. The street has 4 houses and the first address is 65. I am at the first address 65. What is the final address? 65 is the first address. So second 66, then 67, then 68. Okay, final will be 68, which is 65 plus 4 minus 1. Okay, understood na? That is the logic I am putting down. So you have to always do that minus 1. Okay, so what is this answer now? Okay, what is this answer now? Okay, first of all, 2180. Okay, plus 1,000,000. This 000 no effect. This 2 plus 1. Okay, 3180 minus 1. Okay, now here I know many students will make a logical mistake. They will write down the answer as 3179. Let me write down the wrong answer also. Okay, 3179. No, it is not decimal. Okay, it is hexadecimal. What comes? Okay, before 80 is not 79, it is 7F. So answer is 317F. The final location is 317F. It is 3179. Okay, normally many people write it, but that is a mistake. You should know that mistake area also. Okay, why it happens? Because normally you have the habit of solving in decimal, but this is a hexadecimal based problem. Okay, the 317F is the answer. 317F. Next question. Determine the memory address range. Okay, right. Memory address range, I'll be more specific. Okay, memory address range of a memory chip connected to 8085 microprocessor. Okay, now 8085 microprocessor actually has how much bits of address? 16 bit of address. That means it has 16 address lines. Okay, it has 16 address line. Now the memory address given is 8k cross 8. Okay, 8k cross 8. Okay, that means at a single location 8 bits will come, which is also equal to bytes. Okay, this 8 bits is equal to 1 byte. Okay, so I can say the memory is 8 kilobytes. I can say like that, the memory is 8 kilobytes. Okay, 8 kilobytes means what is 8k? 2 raised to the power 3, kilo is 2 power 10, that is 2 power 13. So how many addresses the memory will have? The memory has total 2 power 13 addresses. Every address can store 1 byte of information. Okay, and 2 power 13, okay, requires 13 address lines. To form 2 power 13 addresses, 13 address lines are required. And that is why A12 to A0 are written here, starting from 0 up to 12. How many address lines are required? Okay, to address 2 power 13 locations, 13 address lines are required. Okay, the rest 3 address lines should be for chip select. Okay, so here 13 address line to form addresses. Okay, 2 address line are shown for chip select. Okay, this is what is given here. Okay, in chip select 2 address lines are coming up. Okay, and 1 is unused. And this is what, when some address lines are unused, that is what is known as partial memory decoding. That is known as what? That is known as partial memory decoding. And that one address line, so that can be taken as X, which could be 0 or 1. Okay, if it is unused, it could be in any state. It could be 0, it could be 1. Okay, if it is unused, it could be 0, it could be 1. Okay. Now, what is the memory addressing? See, what is the type of chip select signal given here? Active low. That bubble or bar both are a symbol of what? Active low. Active low means whenever 0 comes up here, then only the memory chip is selected. If 0 does not come up here, no address will be selected. To select the address, first you have to select the memory. Okay, and to select that particular chip, you need a 0 here. Okay, and what is the output of this OR gate? A14 plus A13. Okay, right. Chip select. For chip select, you need A14 plus A13. The output of that should be 0 because it's an active low chip select. Okay. Now, what can be 0? If X plus X is 0, both have to be 0. A14 also has to be 0. A13 also has to be 0. Then only, because if any of them was 1, 1 plus anything will be 1 in Boolean. 1 plus X will be 1. Okay. So now see, what is the 16-bit address? A15. Okay, A14, A13 for chip select. Okay, I'll break it into 3 parts. This is unused, that means 0. And starting from A12, A11, A10, A9, A8, A7, A6, A5, A4, A3, 2, 1 and 0. Okay. Okay. Now see, this is the first address. Whenever you are required to form the first address, take all zeros. Okay, and whenever you are required to take the last address, because we have to say the address range. Okay, so first address all zeros, last address all one. Chip select will be fixed. Okay, chip select will be 0 0 and this is X. Now X can have 2 cases. That is what the point is. Okay, If x is 0, what will be the address selected? If x is 0, the address will be like 0000. Okay, see, at least this much you can say. Now, what is this? This is 0. Okay, this is 0. Okay, this is, sorry, this is also 0. And this, okay, is unknown. Okay, this is unknown. Okay, but 1111F, this is 1111F, and this is also 1111, that is all. Okay, so what is going to happen now? Okay, if x was 0, this also will become 0000. That means 0000 up to this will become 0001. That is 1 triple F. This will be the address range. Okay, if x equal to 1, I will get a different answer. If x is 1, this becomes 10000. That is 8. Okay, then 000. Then this is 1001. What is 1001? Is 9 and 9 triple F. Okay, so there are two answers. And that is equal to, yeah, that is why C option will be correct. The address could be 0000 up to 1 triple F, or it could be 8000 up to 9 triple F. Option number C. Two possibilities are coming. Okay, that is why two possibilities are coming, because of unused address line. Okay, on chip select signal, another question. This is the third homework for you. Okay, 2 from programming and 1 from memory interfacing based on this chip select signal. Okay. This time I have given you the address. You have to form the address range 1000 up to the 2 triple F. Okay, what should be the chip select? What should be the chip select? Okay, I'll stop here. Anyways, this is 25th question. 3 given as homework. Okay, and as I told you, all instructions you will find at the end of the PDF. Okay, all instructions for your revision you will find at the end of the PDF. Okay, PDF I'll share in my Telegram group. Yeah, but for all of you, exam is now very close. The examination is on 26th and 27th. Okay, and the AP Victory Test Series, okay, AEE Victory Test Series, okay, with all the 3 full mock tests is now. And we are on 22nd. So all the 3 tests are live. You can P is 89 only, and in all the 3 mock tests has come up for this. A lot many students are writing it, so you can see that your real-time performance, a good rank where you can still improve in the next 3-4 days before the examination. The platform will be home live app. Okay, guys, if you or your friends are planning to prepare for the upcoming GATE, any online course, to you the online scholarship test, okay, targeting specifically GATE 2027 and 2028. Okay, applicable for online courses, that is live as well as recorded courses. Okay, this test is going to happen on 30th of August. Okay, at 6 p.m. Okay, and the students getting rank 1 to 5 will get a flat 100% scholarship. Based on your performance, you are entitled to get huge scholarships. Okay, the syllabus, the pattern, everything is mentioned here. Okay, the important time is next Sunday, 30th of August. Please remember this. Okay. And also, guys, the new offline batches for GATE 2027 at our Hyderabad center. Okay, the new offline batch. Okay, for okay, starts 29th of August. That is next Saturday. And for electrical, the new offline batch starts 3rd of September. Okay, start. Okay, these are some. Okay. As always, I will share my PDF with the password protection. Microprocessor MP8085 will be the password for the PDF. Okay, password for the PDF. Okay, I really apologize for the technical issue here. The sound was not working today properly. Okay, but we have to because the time is very less. And Monday again, many of you would be writing Coal India exam as well. And then immediately AEE exam came. For that reason, I thought, okay, with some difficulty, with some hurdle, let us carry forward. Okay. At least you will understand a bit. I know it will be little inconvenient, but sometimes it is okay. But I really apologize. There was nothing that we could have done at that point of time. The PDF will be shared in my Telegram group. Okay. This is the name of the Telegram group. PDF will have a password protection. Please note down the password MP in small, MP8085. Okay. Thank you so much, dear. Thank you, all of you.